class the called the cross aldol condensation. So we are undergoing the reaction where the alpha hydrogen will be involving, either the presence of alpha hydrogen required or absence of the alpha hydrogen required. So if it is alpha hydrogen is absent, what did call the reaction as? The second type we are doing over here, oh, it would be third type actually. It is called as the Cannizzaro reaction. What is the name of the reaction? It's called as Cannizzaro reaction. So Cannizzaro's reaction may, we see the compound, the reactant will not have, the condition is the will not have alpha hydrogen. So such compounds, they participate in the Cannizzaro reaction. So what is the condition over here which you need to remember is reactant must not contain alpha hydrogen. Okay, so if you are taking aldehydes or you are taking ketones ke sath, it is not possible, that obviously will have the alpha hydrogen. So only applicable compound is aldehydes, right? So aldehydes which do not have alpha hydrogen, correct, which do not have alpha hydrogen, they participate in this reaction. Okay, they go for the Cannizzaro reaction, and they treat it with the alkali and they give a compound. So what is the condition over here? Let me highlight. Only a aldehyde is participating. It's not like aldol cross and reaction where aldehydes and ketones both are applicable or eligible. Here only aldehydes only eligible because they can have a compound where alpha hydrogen must be absent. So let's see one example. From aliphatic aldehydes, I'm showing you a compound is formaldehyde, which is as exception I told you, right? It means you do not have both the sides alkyl group. Whenever alkyl is present, then with respect to the functional, then next carbon will be called as alpha carbon. But since we do not have carbon over there, we cannot say the hydrogen which is present with the carbon is alpha hydrogen. Are you clear? So alpha hydrogen must be absent. This is the most important condition for the Cannizzaro reaction. So which compound can have absence of the alpha hydrogen is the formaldehyde, right? It does not hold alkyl with it. So next to the carbonyl alkyl will be called as alpha carbon, and the hydrogen present with that is alpha hydrogen. So we do not have that, the condition in formaldehyde, right? So what is the name of this compound? Hridaya? Aldehyde, formaldehyde. So we will be taking the 2 moles of the formaldehyde. Are you clear now? The condition with the condition?
Yes,
Hridaya, are you clear? Okay, good. So here we will be taking 2 moles of the formaldehyde here. So it treated with the KOH in a concentrated medium. So we get the compound over here, right? First compound alcohol, and the second compound, since we have potassium over here, that will be giving the ester potassium compound. So remember, when formaldehyde undergo the Cannizzaro reaction, it gives a redox reaction basically. Okay, so that will be one compound will be producing alcohol, means hydrogen ka addition, other compound mein oxygen ka addition. So we get a compound as called alcohol with the first compound. So since you have O, right, so this electron shifts over here, right? We get the OK, no, dissociated over here, not OH minus and K plus, not like that. So we get the H plus free over here. This carries the negative charge over here. So we get the O and K removed from it, and this goes towards to, now here what happens, we get the positive where we have carbon positive ion right there if the attraction happens, and this goes to the negative side, this carries a negative side. So H goes to O minus and K goes to here negative side, sorry, just a minute. K goes to O, K goes to carbon side. So the product forms over here. Look at over here. We can say OH, and rest all will be as H, right? Here will be H. So look at over here. We can say this H coming out. From where do we get the H? Now this also releases hydrogen ion as well. So proton will be removed from here because O minus, it is coming over here. So we get either the compound as, right, carbon double bond oxygen right here, as it is now shifting again back, and OK, right, because OK carbon ke paas aayega, right, and we get the hydrogen. So you can see around this we have 4 sticks. What do you call this compound as the potassium formate? What do you call this as? This is as the methanol methanol, not methanol, and this is as the potassium formate. Hridaya, is this clear?
Yes, ma'am.
Okay. So can I remove now all these arrow? It is clear, right? The concept?
Yes, ma'am.
Okay. So we get the compound one as the alcohol and other compound we get as the ester compound, that is formate, potassium formate. This is the one example, Hridaya, for taking aliphatic aldehyde. What is the example? Formaldehyde. This does not hold alpha hydrogen with it. So that's the reason we have taken formaldehyde. Let's take one aromatic aldehyde. Aromatic aldehyde mein benzaldehyde is the compound. So CHO taken as the benzaldehyde, 2 moles of the benzaldehyde. This benzaldehyde treated with alkali, that is sodium hydroxide, in concentrated medium. So you can see from the beginning we are doing this reaction where the alpha hydrogen involvement take place, that is aldol, cross aldol and canizaro. All these reactions are getting treated by the alkalis like sodium hydroxide, barium hydroxide, isn't it? So here again the compound is getting treated by the KOH. KOH is alkali, right? So we have the same reaction, but some properties which we need to follow, like conditions also given over here. They should have alpha hydrogen, they should not have alpha hydrogen. So when they have alpha hydrogen, they go for aldol reaction. When they do not have alpha hydrogen, they go for canizaro reaction. Okay, so when they undergo the canizaro, the product will be alcohol and ester, right? So here we have done with the aliphatic and now we are doing with the aromatic. So aromatic ke liye we have taken sodium hydroxide. The same behavior, it is also alkali. So we get the alcohol product with one benzaldehyde, it is 2 moles. So one benzaldehyde will give the alcohol product. Other benzaldehyde will take the sodium oxide and hydrogen ion gets free. So we get other benzene ke sath, what do you get as the compound? COONA. What do you call this as? Sodium benzoate. Is this clear? Sodium benzoate, and this is what compound called as benzyl alcohol. You wanted to learn the mechanism? You have 2 moles, isn't it? Benzaldehyde, carbon double bond oxygen, hydrogen. Then again benzene ke sath carbon double bond oxygen and hydrogen. This is what you have benzaldehyde with you, right? Treated with the sodium hydroxide. Clear? This sodium hydroxide will be ionizing in this way. Clear? We get the loss of hydrogen from here. So this is in going in the form of H plus. This is taken by this compound. Clear? This goes to shift over here, O negative, right? This takes the O negative, right? The electron now present between this is now moved. This hydrogen will be going and attacking to this, right? And similarly, this hydrogen comes and attached over here. And now ONA goes over here. Did you understand?
Yes, ma'am.
So if you want this picture, I will keep this in a separate so you can understand how the movement is taking place. Clear? You can understand. Huh. This is your key point. You can take help of this in understanding the chemical reaction, how electron displacement is happening. Okay? Is this clear?
Yes, ma'am.
Good. So now we are done with this category where we have alpha involved and alpha does not present, right? We are completed now. Let's start the carboxylic acid. Okay. So what is the symbol of carboxylic acid? It is COOH. Correct?
Yes.
Yeah. So carboxylic acid symbol is COOH. If any compound holds the symbol, we call the compound as a carboxylic acid. What would be the structural formula of the carboxylic acid? How will it be represented? So structural formula ke liye we take the carbon double bond oxygen, oxygen single bond hydrogen over here. So what you can see over here, we have around the carbon 4 stick maintained at any cost, and oxygen के around 2 stick. So all these sticks, what they are representing their valency, like very simple. Hridaya, you can see carbon के पास tetravalent behavior it has, so it maintains its 4 stick around it. Oxygen is bivalent, so 2 sticks. So whenever you draw the diagram, you can remember its valency and you can draw the stick around it with the other atom, and uske next atom ki bhi property we must know, then only the sharing can happen right among them and the structure can be drawn. So this is the structure for the carboxylic acid. Are you clear? Okay, next come to the suffix. What do we use the suffix especially for IUPAC nomenclature? So we use over here as the oic acid. What do you use as a suffix? So there oic acid. Remember methanoic acid form like ethanoic acid, propanoic acid. Oic acid will be added over here. Clear? Let's begin the IUPAC nomenclature then. The first. Any doubt in the structure and the other representation part? Hridaya?
No, ma'am.
Let's begin the IUPAC nomenclature then. So when we do the IUPAC nomenclature, the rule we can remember the same prefix number, prefix name, root word, right? And the primary suffix and E will be dropped off the primary suffix and added with the secondary suffix. Rules goes same way. We don't have any change in the rule. Okay. Only the thing you need to remember here as the oic acid. So let me give the general formula which will be followed over here is alkanoic acid. What is that? Alkanoic acid. So after applying the rule, you could see that we are following the name as alkanoic acid. Let me take one example, Hridaya. This is carboxylic acid. So you can have the side complete, this is structure C double bond or OH. This is representing carboxylic acid. Hydrogen present over here. Then how to number it? First then step numbering, then naming. So numbering के लिए always the functional group carbon is considered one carbon. This carbon is considered one carbon, isn't it? What is the root word here there for one carbon? Meth, right? Okay, single bond is present between hydrogen and carbon. So we can say the primary suffix as AN, right? E will be dropped and we are adding oic acid because functional group over here secondary suffix as the aoic acid. So the name goes as methanoic acid. So the same, right? Alkanoic, methanoic, both are similar. Correct, Hridaya?
Yes, ma'am.
Will you try this compound by yourself? Write the name of this compound. I'm giving some more compounds. Try by yourself. If you find any difficulty, ask me. No worry. Okay?
Yes, ma'am.
Yeah, Hridaya. Try this. How was your biology paper? Biology practical exam? Went well?
Yes, ma'am. It was
Good. Good. When do you have chemistry?
20th.
Okay.
Ethanoic
Yeah,
acid.
yeah, there. So why you are taking too very much time? Don't take too much time. Huh? We have to finish lot portion, right? Ethanoic acid. This one, Hridaya, try this. Very good.
Butanoic acid.
Exactly. Butanoic acid. You know the concept, Hridaya. You don't be scared, no? Very nice. 1, 2, 3, 4. It's butanoic acid. Can I give you the branch form example also?
Yes, ma'am.
You can try, right? Very good. So let's do this. CH3 whole, right? Twice we'll be writing CH down is the one branch and the CO. No worry with the branch. Rule goes same. This will be the number one carbon, 2 and 3. We can go down also, correct? But select the long carbon chain from the carbonyl side where carbon functional group is present, that side. And select long carbon chain, give least position to the locant. And while writing the name, remember prefix number, prefix. So this is our prefix. Clear? Hridaya, can you try this name? Root word plus primary suffix and then secondary suffix. E will be dropped.
Ma'am, could you do this?
Okay, I'll do this. So here, Hridaya, we have carbonyl present over here. This is 2 and this is 3. We have done the numbering. Now naming ke liye we'll follow the rule as usual, prefix number. What is the prefix position? 2. What is the prefix name? Methyl. So we write methyl. What is the root word Hridaya? 3 ke liye prop. Correct? Okay. What is the bond present between them? AN. E will be dropped and what we are going to add as oic acid. That's all.
Oh, yes, ma'am.
Will you do one example?
Yes, ma'am.
Very good. Chalo, we'll do this. Write the name of this compound.
Is it 2-dimethyl propanoic acid?
Come again. 2 dash.
I said 2-dimethyl. Oh,
2 will be represented twice. For we can say individually we can go for each methyl. The position will be mentioned 2. So it goes dimethyl. Okay. And
propan
what is the number of carbon?
3.
Prop 3, right? So prop and ANE will be dropped by adding oic acid. Right, Hridaya?
Yes, ma'am.
Okay. Do this, Hridaya.
Two, 3.
Very good. 2,3 dimethyl. Very nice.
Butanoic acid.
Butanoic acid. Super. Good. So you are learned how to write the IUPAC for the carboxylic acid. Now let's do in aromatic carboxylic acid. ठीक है Hridaya? So this compound has the name benzene carboxylic. Either you can go right like this, or you can have a other like old rule what we had in IUPAC called benzoic acid. It was called as benzoic acid. So you can call by this name as well. Okay, Hridaya?
Yes, ma'am.
Cool. Okay, let me introduce here with the carboxylic and aromatic compound, the 2 carboxylic acid present over here. This compound is called as phthalic acid. What do you call this as? By general name, not the IUPAC name. Okay, phthalic acid. What do you call this as? Phthalic acid. So this compound is quite common for here, this chapter. We have actually a preparation of this, right? And involved here. So let's learn the IUPAC of this compound. What is the IUPAC name? This is common name, okay? Common name of this compound. So what would be the IUPAC name of this? Let's learn. Any one side you can go as the carboxylic position mentioned. Benzene first will be written and the position of the carboxylic acid. Since 2 are present, we write di and carboxylic acid. You can write even dioic acid, but mostly in aromatic we use the dicarboxylic acid. Clear, Hridaya? Clear? This is where we have COH directly attached to benzene ring. Let's do one example where COH indirectly attached to benzene ring. So here the COH, which is indirectly, means first it is attached to hydrocarbon and then it is attached to benzene ring. So it is indirectly attached, right? It's a, we can say as a side chain. Phenyl ring will be considered as a side chain. So now here this will go as a prefix. Whole ring goes as the prefix. What is the name of the prefix as? Phenyl. This is considered as the prefix. Okay. Then root word mein this carbon chain go as the root word. Clear? So here let's begin. 1 carbon, 2 carbon. How many carbons? Because COH present here, right? So that carbon consider carbon 1. So let's begin the naming. naming will go as the position of the phenyl is second. So 2-phenyl. Are you able to understand, Hridaya? I will, otherwise I'll explain once again. 2-phenyl, okay, ethane oic acid. Is this clear?
Yes, ma'am.
Are you able to understand, Hridaya? The phenyl ring is not directly attached or not directly containing the COH. First, it is attached to hydrocarbon and then it is attached to, we can say, the benzene ring. So hydrocarbon ka means that is single covalent bond. Alkane ke saath it is attached. So we call it as a second position phenyl ring, 2-phenyl ethanoic acid. Is this clear?
Yes, ma'am.
So, Hridaya, we are done with the IUPAC. Let's start the structure and then we'll start the preparation. So, structure of carbonyl group. How it is represented. Let's learn the structure. You can see the screen, right? It is visible to you. Why I have highlighted? Because the structure, I'm going to show the electron displacement over here. So look at over here. Here, Hridaya, you are able to see the screen properly, right?
Yes, ma'am.
Good. So the two lone pairs of the oxygen over here, we are shifting this bond towards to the oxygen. So oxygen carries negative ion over here. This electron pair will shift over here because this bond has now relocated. It has moved, displaced, any word you can use. So this pair will occupy or fulfill that position. Okay. So we have this structure. It's called the resonance structure, right? So what is the resonance structure of carboxylic acid? Let's see over here. This turns to O negative, right? Bond shifted over here, and here we get the hydrogen. So one pair will be left, and this, since giving out the electron pair for formation of a bond, so this carries positive charge. Are you clear? And the same way, we can get back the electron bond over here, electron pair back, and this shifted over here. So possibility, that's the reason it is represented by double-headed arrow, which is a symbol of resonance structure. So basically, I'm talking with you resonance structure. Is this clear, Hridaya?
Yes, ma'am.
So you are able to understand the electronic displacement, how the electrons are displacing from one position to another. So you can see the when this bond breaks, the a pair goes away, right? And that's the reason oxygen acquire a negative ion over it. And same with this pair can fulfill this position, right? Because carbon is showing loss, right? It is not showing 4 stick around it. So this can be fulfilled by the oxygen pair. Since oxygen giving out its pair, so this carries a positive. Positive means lack of electron. Clear? Right?
Yes, ma'am.
Good. So that's the reason I have highlighted I have made the screen little use. Now we can go for the preparation. Let's begin the preparation of carboxylic acid. So look at over here. We are learning carboxylic acid individually. Why? It means as a separate compound, not along with the aldehydes or ketones. Why? Because we have a reason for it. You can see the carboxylic has, after oxygen you have hydrogen present, right? But in that compound, in ketone or in that compound, we have the carbonyl group. This also contains carbonyl, but the two sticks may one stick alkyl and other stick hydrogen for aldehyde, and there the two sticks are alkyl. So it is quite different compound. What group we have extra over here is OH group, where the hydroxaldehydes and ketone they do not have this group, right now. That's the reason we are learning this in a separate. So preparation of carboxylic acid, let's learn how do we do the preparation. Very simple. As alcohol gives the aldehydes and ketones, same way alcohol will produce the aldehyde, then from aldehyde we can have the carboxylic acid. So it is kind of chain reaction. So oxidation means addition of oxygen happens, and we get from alcohol say aldehyde, and then aldehyde oxidation we get the product as carboxylic acid. So very simple reaction. The first preparation we are doing from alcohols. Clear? So 1 degree alcohol basically we will be taking here. right? Specifically 1 degree alcohol. When we have to prepare aldehyde, I'm telling 1 degree alcohol only will be produced from the aldehyde, and same way 1 degree alcohol will give out the aldehyde, right? 2 degree ketone ke liye, right? And ketone can give 2 degree alcohol, like vice versa we can say. So let's take example of the 1 degree. 1 degree ka symbol is CH2OH always. R can be any number, no worry. So this is the general example. 1 degree alcohol we have taken, right, and treated with the strong oxidizing reagent. Either you can take KMnO4 or you can take K2Cr2O7, any oxidizing reagent you can take and show the reaction. Even it can be done in potassium carbonate also, right? Potassium carbonate, which is taken in aqueous form, in this also it is a possible. Suppose if we are taking potassium carbonate, then it will produce directly RCOK. Then RCOK can be acid hydrolyzed and can produce a compound called carboxylic acid. We get as the carboxylic acid. Is this clear, Hridaya? So
Yes,
very
ma'am.
simple reaction. Let's do one example over this. Can you tell, help me out with the CH3CH2OH. This is the ethanol, 1 degree alcohol ka example. I am treating this with the same reagent. What will happen, Hridaya, over here? Can you help me out? We get as the compound CH3CH, right? This whole compound getting converted into, let me tell you, COOK. Are you clear?
Yes, ma'am.
Okay, then what we do, acid hydrolysis, CH3O plus. So acid hydrolysis में this compound, right, will be taking CH3COOH. KOH goes out. So we get as the compound CH3COOH. What is getting removed? KOH. So H3O plus say we get the compound H plus and OH minus. OH minus here, plus and minus. So obviously this goes over here and this goes over here. So KOH is out and we get a compound as acetic acid. This is common name. What will be the IUPAC name? Ethanoic acid. What is the IUPAC name of this compound? Tell me. 2 carbon, Eth, single bond, AN, E dropped by adding oic acid. So name is ethanoic acid. So what ethanol gives? Ethanoic acid. Clear, Hridaya?
Yes, ma'am.
Do you require these all arrows or I'll remove?
You can remove.
Okay, good. You're finding difficult or simple? You can learn and prepare. It's easy for you. Explanation is quite okay. You can understand.
Yes, ma'am.
I'll go little slow.
Yes, ma'am.
I'll go slow.
Ma'am, this is fine.
This is fine. Okay, thank you, Hridaya. So let's see over here. The next one, we will be preparing it from the toluene. What is toluene? So it means we will be getting aromatic carboxylic acid. So what do you mean by toluene? Remember, benzene contains CH3. What do you call this as? Toluene, right? Same mechanism over here. This is aromatic, no worry. We will be oxidizing this compound with the KMnO4 and the KOH over here. It is called the alkali KMnO4, alkaline KMnO4. That's all. Heat required. What do you get as the product over here? You have only one carbon, right? So no worry, we get the COOK, that carbon hydrocarbon gets oxidized. We do the acid hydrolysis and we know what happens in acid hydrolysis. This gives H plus and this gives OH minus. OH goes to the positive, H goes to the negative. So we get the product as benzoic acid and KOH is out. Clear, Hridaya?
Yes, ma'am.
Right. Next reaction, preparation we are doing. Next, this big is fine, right? Enlarging a screen is not an issue, right? For you, Hridaya? Are you
Yes, ma'am.
using laptop or computer?
Ma'am, I'm using laptop.
Okay, so enlarging the screen is not an issue, no, for you?
No, ma'am.
Okay, thank you, Vidya. Let's begin now from we are doing next third preparation from propyl benzene. Okay, so propyl benzene aromatic over here, the compound, let me write the bond inside. If you don't feel like confident with the bond, you can go for the circle also. Both are applicable. Okay, CH2, CH3. So this will be treated with the KMNO4, right? KOH, heat, again heated. So we get the same compound, right? So let me tell you, it's very quite interesting part. Sometimes what happens, children make mistake with this reaction. They think there are three carbons, so these carbon must be maintained. No, Hridaya. Whatever the hydrocarbon comes over here, please make a note. All goes out and leave the one carbon over here. That gives a compound as benzoate, potassium benzoate. This only gives the compound by acid hydrolysis as the benzoic acid. So it is very, very important. This question is sometimes children get confused. So it's a very important for in conversion, right? They give right the main product. Okay, Hridaya?
Yes, ma'am.
So you can see here, whatever number of carbon you have, doesn't matter. It is going to lead only one single compound, that is potassium benzoate always. What is called this as potassium benzoate. And this is what propyl benzene. So first you have taken with the one carbon, right? That is toluene, and then you have taken the used number of carbon. Whatever number of carbon does not changes, right here we get as the compound benzoic acid. Clear? Let's learn from nitriles. So what is nitrile, Hridaya? It's CN, right? Cyanide. It is always called as nitrite. What type of bond present between them? Carbon triple bond nitrogen. That's why for always carbonyl group, na, we will be utilizing this compound as we can say reactant. क्योंकि here we have always available carbon triple covalent bond. So nitrogen ko we can remove, right? That can be removed by hydrolyzed, right? Hydrolysis if we do, so we can have the carbon oxygen bond, carbonyl bond, and again hydrolysis you do, the ammonia will be released and we get the carboxylic acid over here. So very simple, because we have the carbon double bond oxygen and OH ka production. So acid hydrolysis, just continue two steps, you will get the product. Okay, so let's see over here. Carbon triple bond nitrogen, right? What did I say? Nitrile ka what I'm doing? Acid hydrolysis. Correct, no? So I would be taking H plus and OH minus. This will be symbol. Whenever I say H3O plus, that means H plus and OH minus. Anything you can write. ठीक है Hridaya? Any one can be written. Right, Hridaya? Are you able to understand?
Yes, ma'am.
Okay. So this is the symbol. We go R. This bond will be now formed carbon double bond oxygen, and this gets the hydrogen, right? This is a form of amine. So what do you call this as? Amide. Now amide ka when you do the acid hydrolysis, what you will get as the product? This goes out and OH goes over there. Clear? Very simple. So R, C double bond O, OH, what is this? Carboxylic acid. You get as product, right? And ammonia is out. This is taken by NH2. So we get ammonia. Okay? Did you
Yes.
understand? Ah. So OH comes to form the bond with the carbon, and NH2 takes the hydrogen and goes out in the form of ammonia. Now do this reaction by yourself. So there CH3C triple bond N. What happens when this methyl, we can say ethene nitrile you can call, or methyl cyanide. Okay. What is happening when acid hydrolysis is done of this compound? Hridaya, complete this reaction. Yeah, Hridaya, tell the product.
Uh, CH3. CONH2.
Exactly, it is acetamide. Very good. The second compound, Hridaya, identify.
Uh, CH3COOH.
Yeah, CH3, C double bond O, right, and OH. Plus we get as here ammonia. Clear?
Yes, ma'am.
Good. So let's begin now the next preparation. Okay, from Grignard reagent. What is Grignard reagent? R MgX. I told, right?
Yes,
It is
ma'am.
very important for 1 mark question, Rudra. Prepare RMGX is called Grignard reagent. You can take any example, CS3MgBr. You can take examples, may C2H5MgBr, CS3MgI. You can take anything, you can take. Okay, C2H5MgBr. So these are the examples, Hridaya. Do remember 1, 2. These are the examples. Clear? Let's begin now. R, right? MgX is the Grignard reagent, which will be doing with the solid carbon dioxide. Means with the dry ice, it is getting treated. So reaction is with the dry ice. From Grignard reagent, and the reaction is with first carbon dioxide. So this is dry ice. Okay, so solid carbon dioxide, let me mention solid carbon. In parties and all, they will make the smoke, na?
Yes, ma'am.
That is solid carbon dioxide. So carbon here, double bond oxygen and double bond oxygen over here. Let me tell you, this bond will shift, correct? And positive formation here, mgx will have a positive. So basically what happens, this can attack over the carbon and the mgx can go over here. So we get as the product rc, right? Okay, pass mg will come. Right, it's very simple, Hridaya. Look at over here, this part, whole part gets the positive ion. So when it gets the positive ion, this part will get the negative ion. And here we have positive and here we have negative. So this carbon will attack to the carbon side, positive side, means alkyl groups, R group. Correct? That's the reason R single bond C is formed. And Mg, where will it go? To oxygen, where we have negative charge present. Is this clear?
Yes, ma'am.
Good. So we get double bond as well, oxygen over here. This is your adduct. Always we say the addition ka product, but here it's adduct is formed. Acid hydrolysis will be done for this. And what do you get over here as the product? R COOH and Mg gets the MgOH. So how will you get this reaction? Look at over here. So from acid hydrolysis, we have H plus and the OH minus. Okay. So MgX, this part gets the positive because here the ionization happens. So OH minus goes to positive, H plus goes to over here. So what do you get as the product? R C sorry, C single bond OH, correct? And we have double bond O. What do you call this compound? The carboxylic acid. Same way, anywhere you can double bond brought the bagal mein, kahin pe bhi, no worry. Right? That is always 4-stick maintained. And then the byproduct MgOHX. Clear, Hridaya?
Yes, ma'am.
This part is clear, right, to you? Okay, Hridaya. So now the next example on this, which is very important, you will try and help me how to do this reaction. Okay. CSC-MgBr. I would tell the name as methyl magnesium bromide. Okay. I'll call it like this. This compound will be treated with carbon dioxide, solid carbon dioxide, which is dry ice. What will it produce? The bond is shifting over here, right? This bond cleaves, this gets the positive, this gets the negative, this goes over here, attack. Correct, Hridaya? And this pair gets extra pair. So what do you get over here? The product CH3, C double bond ki jagah single bond minus MgX comes over here. Double bond retains as well. There we get what now? Shifting acid hydrolysis we do. H3O plus. So what do you get? MgOHX we will get, and H plus comes over here. The compound CH3, COH over here, double bond oxygen plus MgOHX. Clear there?
Yes, ma'am.
So always what do you get as the compound? Alkyl with the carboxylic acid. Okay, will you try this one? Hridaya, do this by yourself and tell the product.
Ma'am, I need to refer it.
You need help or the previous slide you want me to show?
Yes, ma'am.
Okay, no worry. You can ask Hridaya, don't hesitate. You
Yes.
can see now. This will be helpful, right? This is enough. So you can refer this one.
ma'am.
Okay. So what is the product Hridaya? Here you will get C6H5, C double bond O down, OMGX ऊपर आएगा, right?
Yes,
And
ma'am.
then again acid hydrolysis we do. What do you get as the product Hridaya? C6H5 will take the COOH group. What do you call this as? Benzoic acid. ठीक है, C6H5 is the phenyl ring. ठीक है, and COOH. This is the compound. So we get as the benzoic acid. Clear? Plus MgOH X as the product. Clear, Hridaya?
Yes, ma'am.
Okay. Hridaya, we can have some break for 5 minutes. No
Yes,
worry.
ma'am.
Okay. We'll start the, we can say 2 more preparations we have. And that is very simple. That one we can do the acid anhydride ka. We do basically hydrolysis. So anhydride, remember the formula? Suppose if I'm writing CH3, and here the C double bond O, C double bond O, and CS3. This is acid anhydride or acetic anhydride, isn't it? So when we do the hydrolysis of this compound, we know basically it breaks into 2 carbonyl compound, right? The one we get as the carboxylic acid only, and other with this compound will come. Similarly, here when we are doing hydrolysis, so it is understood we are providing H plus and OH minus. H goes over here, this oxygen, OH comes and attached to the carbon. So it is very interesting, Hridaya, we get the 2 moles of acetic acid. Can you see?
Yes, ma'am.
Can I write like this? So it's very simple reaction. Acid hydrolysis reaction, acetic anhydride hydrolysis is very, very simple. So just you need to learn that how the bond present between the carbon and oxygen, we get the 2 moles of carboxylic acid. Suppose we have taken general formula RCO whole twice O. Okay? This compound is taken and taking acid hydrolysis. So what do we get as the product? 2 moles of RCOOH. Is this clear? So let's take one example for this. This will be very, very easy. So after 5th preparation, we are going for the 6th one. And the 6th preparation heading is from anhydride. Okay. Let's see over here. Suppose C6H5, COO, and O is given. So, right, hydrolysis we are doing and we get the product 2 moles over here as C6H5 COOH. What do you call this as? Benzoic acid. Clear? Suppose other side, in this we have compound like this C6H5, okay? COO, then COCH3 we have. CO and CO. Correct. Other side CH3. Instead of writing 2 similar, we have written 2 different. That's all. So if I wanted to draw, I would be able to make C6H5 C double bond O, this is called CO, oxygen connected, which was middle. Then again C double bond O, and here CH3. Now it is clear there. When we do acid hydrolysis, what do you get as the product? Cleavage. H comes over here, OH comes over here. So both the alkyl, aryl, both the compounds will take COOH. So you get benzoic acid as well as acetic acid, right?
Yes, ma'am.
The next is from esters, and this is the last one. So how do we do from esters? Esters actually the C double bond O, O, R dash. Clear? We do H2O, acid hydrolysis, acid written over the arrow. We get as the product over here, carboxylic acid, and OH. So from ester, basically we get one acetic acid and one alcohol, one carboxylic acid product and one alcohol. So let's do one example. C6H5, C double bond OO, and we have other side C2H5. Okay, Hridaya? So can you tell the product, Hridaya? Take the help of this and tell the product. Hridaya, tell the product.
C6H5, C double bond OH.
OH, very good. Plus
C2H5OH.
yeah, good. Come to properties now. And in this properties, we'll start first physical properties. Let me introduce the most important property of the carboxylic acid. Carboxylic acid will have higher boiling points, right? Higher boiling points than any other functional group. This is higher among all, we can say, in hydrocarbons. So why does it produce higher boiling point? Let me tell you the reason behind it. If I'm taking acetic acid example, okay, 2 moles of the acetic acid, this 2 moles of the acetic acid would be able to form a dimer of itself compound by producing hydrogen bond. Look at over here. I took this 1 mole acetic acid, theek hai, Hridaya? I'm taking another acetic acid mole and I'm going to reverse it so that hydrogen can make a bond with the oxygen. And similarly, oxygen can come down and can make hydrogen ke sath bonding. So I'm taking the same compound, but I'm reversing the order. Clear, Hridaya? So this will become C double bond. You can see this has come opposite direction. Both are coming in opposite direction, Hridaya.
Yes, ma'am.
And here just little, I enlarge the screen so that you can see clearly. Oxygen, lone pair of electron as usual. How was here? Same way. So what happens when they are attached by this intermolecular hydrogen bonding? Let me share this part. What you call this as intermolecular, and this is the reason. Intermolecular hydrogen bonding. This is very strong and they form dimer with this. This is what we call as the dimer. They produce dimer. Correct. This is a type of a structure we cannot see in other functional group. Correct?
Yes,
Right? So why they are having high boiling point? You got the reason. Correct? This is the first and most important physical property. High boiling points, right? Or higher boiling points of carboxylic acid. Right? This is, we can say, are due to intermolecular hydrogen bonding. Right?
yes, ma'am.
Second property. Carboxylic acids are soluble in water. Obviously, they will be soluble. Right?
Yes, ma'am.
Why? Because they can form intermolecular hydrogen bonding with water. Correct? So, what is the reason? Why are they soluble? Tell Hridaya. Due to the formation of same reason, hydrogen bonding, but यहाँ पे it will make hydrogen bonding with water. Clear?
Yes, ma'am.
So these two physical properties you need to remember. They are very, very important. But when you go for higher, right, solubility decreases. Let me mention this point. This decreases with increasing number of carbon atoms. So higher carboxylic acids are not soluble. They are insoluble. Okay, remember this. So reason, they sometimes if they ask what you will give the reason, write that also. This is due to increased hydrophobic. Hydrophobic means hating water. Hydrophobic, PIC. Hydrophobic interaction of hydrocarbon part. As the more hydrocarbon increases, that becomes more hydrophobic, means hating water. Okay, Hridaya?
Yes, ma'am.
Okay, now come to next and the chemical property. When we begin, let me start with the again acidic behavior, acidic nature of this compound. So when we are talking about the chemical properties, the first and most thing comes over here is acidic nature. So how the acidic characteristics are defined over here, because we are seeing here, when you see the structure, you can see you have double covalent bond carbon ke sath and single bond oxygen and hydrogen, and other part is R. So obviously this H can be free from, that can be freed from the carboxylic acid group, and acid in the last as well, right? So when it is dissolved in water, what, how does it react? We know this is like going to no remove hydrogen from it. When it removes what hydrogen from this, right, oxygen generates the negative charge. This shifts over here, this shifts over here, over the oxygen. So we know the resonance structure also develops over here. Carbon gets the oxygen negative charge, and we get the double bond oxygen over here. So resonance structure also showed, and we get the H plus freed, right? That combines with H2O, and what will it produce? H3O plus. Are you clear, Hridaya?
Yes, ma'am.
See, this is how H2O के पास two lone pair है ना. So when H plus approaches this approaches due to pair of electron. So they make single covalent, sorry, they make a coordination bond. Okay, this is how the bond formation happens between this, and it will have its one pair left with it. Correct? Hydronium ion ka structure is this. Did you understand how H plus is taken by the H2O? So I'll keep at the corner. You can read it. ठीक है? It is visible, right? Clearly everything?
Yes, ma'am.
Okay. So you can see in this a pair which is shifting from oxygen to hydrogen. It is a coordination bond. And this is how coordination, this is covalent bond. So we know H2O में दो hydrogen that is covalent bonded with the oxygen. But the pair which has two lone pairs, so one among that will be shared between hydrogen and oxygen. This is how they generate the coordination bond. And this is hydronium ion called as. Clear, Hridaya?
Yes, ma'am.
Concept is clear, right? So this reaction actually indicates one most important characteristics of the carboxylic acid. So let me introduce over here. Carboxylic acids are acidic in nature. Okay, Hridaya?
Yes, ma'am.
This is the most important property. So let's see the reactions, chemical reactions, which helps to prove. So Hridaya, can you help me? Which are the reactions we can say, by which reactions we can prove the acidic character of any compound? Remember, one reaction with the metal and another reaction with the base. Correct? So metal will be able to displace hydrogen from acid, hydrogen gas liberated, and acid and base reaction gives salt and water. Correct, Hridaya? So one reaction with metal can be shown. And when we say the metals may, we have like many options. We have sodium, potassium, lithium. Okay, so let me take sodium and potassium. That will be fine. That's enough. Okay, etc. What do? They displace hydrogen basically from acid. Okay, that is their characteristic. So if I'm taking RCOOH and I'm treating it with the Na has a property. It is no above in the reactivity series above than hydrogen. That's the reason Na is able to displace hydrogen from acid. So we get 2 moles. Suppose we have taken 2 moles of carboxylic acid and treating it with the sodium. So it removes hydrogen from carboxylic acid and gives a product called the sodium salt, RCOONA. It is also known as a sodium carboxylate salt, right? Here we get, and hydrogen gas displaced, right? This is the one reaction which proves acidic character of the carboxylic acid. So when a question comes to you, how will you show acidic nature? By two chemical reaction, right? So you can write the one metal reaction and other reaction with the base. Correct? Hriday, are you able to understand?
Yes, ma'am.
So reaction with a base. Suppose the base may what we can take, like sodium hydroxide can be taken, potassium hydroxide can be taken, anything. Suppose for example, we have taken sodium hydroxide. So carboxylic acid is a reactant, which is acid. Okay. Sodium hydroxide is alkali. What is alkali? Alkali is nothing. All alkalis are bases, but all bases are not alkalis. Right? Those are soluble in water only, they are alkalis. Correct, but they are base, no worry. So acid and base reaction, what will happen? We get the product salt, RCONA, same salt, but water is the byproduct over here. So the as usual, the neutralization concept, acid plus base, salt and water. So these two reaction can be taken as a reactions to prove that carboxylic acid is acidic in nature. Is this clear, Hridaya?
Yes, ma'am.
Let me introduce one more reactions. Carboxylic acids are weaker acid, not a strong acid. They are organic acids, right? So carboxylic acids are weaker acids. Why? Because they react, because they are able to react with weaker base. So this line is indicating its strength. What is the weaker base? Let me take example. Sodium bicarbonate. You can write the name, na? No worry, you are aware about the name, right? NaHCO3, what do you call it as? Sodium hydrogen carbonate or sodium bicarbonate? Correct?
Yes, ma'am.
And when the carbonate salt is treated with any acid or any compound, will liberate carbon dioxide. Respective salt gives out the respective gas. Like suppose if it is a sulfate, then sulfur dioxide. If it is a sulfide, then hydrogen sulfide gas will be liberated. Okay. So this is the concept. So if you do the salt analysis, you can see there carbonate salt ko if you treat with the dilute sulfuric acid, what you will get? Effervescence. Effervescence indicates the evolution of carbon dioxide. Then you pass the carbon dioxide to lime water and lime water will turn milky. Did you do this test?
Yes, ma'am.
Yeah. So how it happens? Because carboxylic acid, if it is there, suppose compound, right, and we wanted to prove, but you have done the reaction with the minerals acid, like mineral acid, sulfuric acid. So you took the carbonate salt. It can be bicarbonate, can be carbonate, calcium carbonate, sodium carbonate, potassium carbonate. If you take bicarbonate, since it is containing carbonate with it, so it will liberate carbon dioxide. With carboxylic, both are weaker acid. That's a thing which you need to remember. So here the weaker acid, carboxylic acid, treated with the sodium bicarbonate. So obviously the liberated gas is carbon dioxide. This is how we can say carboxylic acid weak strength can be proven by this chemical reaction. Okay, Hridaya, can we see the chemical reaction? RCOOH treated with the sodium bicarbonate, correct? It will produce the salt. No worry, same salt, RCOONA, sodium carboxylate. Which gas goes out? Same. So only the thing difference over here is carbon dioxide. That's all. Rest all same as the acid base reaction. So basically this is weak acid and this is as the weak base. That's the reason it is giving salt, water, and carbon dioxide liberating. Right? Hridaya?
Yes, ma'am.
Okay. So you have seen the carboxylic acids are weaker acids and they are reacted with a weak base like sodium bicarbonate. Now, let us talk on strength as we have come. So reactions we have done. Now strength. Acidic strength. Okay. So acidic strength, when we are talking of carboxylic acid, it may have some effect by substituting the group. So basically, under this, we are learning effect of substituent. If the substituents are present, how are they going to influence the acidic nature on the acidity of carboxylic acids? Okay. So very simple, Hridaya. The first group is EWG group. What do you mean by EWG group? Electron withdrawing. Electron withdrawing group. Okay. What are the electron withdrawing group? We have like nitro examples, NO2 group. Agar COH के साथ NO2 group is present, then we can say that group is having the NO2 is electron withdrawing nature. CN group, right? Cyanide ion. So this is electron withdrawing group. Clear? Is this
Yes.
clear? Okay. Halide ion, if you have, this is electron withdrawing group. So these groups, what do they do? These groups increases the acidic or acidity of carboxylic acid. So basically we are comparing with the other compounds, okay, by stabilizing. So how do they stabilize? Because they withdraw electron, correct? So the negative ion generation happens over this, and that negative ion gets delocalized all over the 6 carbon, correct? So carboxyl stabilizing the carboxylate ion, carboxylate carbon ion will be becoming anion, carboxylate anion, through delocalization. The delocalization means I'm talking about the resonance structure, right? Of the negative, you have seen, right, how the negative charge generated O, say O negative, and then again bond shifted over here, correct? Charge by which effect? Inductive effect. Okay? Or we can call it as resonance effect. So I showed you resonance structure 2 times, remember, while teaching the structure highlighted. This is the resonance structure. Once I taught, then this bond after before formation, the structure I taught you, where it is gone. Wait. Yeah, this is. Can you see, Hridaya?
Yes, ma'am.
Yeah. So when EWG group present, suppose here we have EWG group present, right? Nitro group present. So nitro group will withdraw the electron. And when it will withdraw the electron, the carboxylate anion will be delocalizing, will be fulfilling the electron, that gap, and that will be delocalized throughout the structure. That is the reason it is stabilized by, we have written the line, it is stabilized by the resonance structure. So this effect we call inductive effect, or you can call it as a resonance effect. Correct? Inductive means minus I effect, it will be shown by this, and resonance means minus R resonance effect, it will be shown. Is this clear?
Yes, ma'am.
Okay, Hridaya. So let's begin now. Examples I have done. So basically the concept, what you can remember is, you can tell that a compound like EWG group stabilizes the carboxylate ion, anion, and strengthens the acidic nature. Now let's do in the second group about the EWG happened, EDG group. What do you mean by the EDG group? It is called electron donating. So this increases actually electron density over the carbon. Okay, let me draw the structure that would help you. I'll draw the structure, then it will be fine to you. Hridaya, can I draw over here? How?
Yes, ma'am.
So I'll take the carboxylic acid. So the double bond oxygen and the negative charge, this and forms over here, this is resonance. Then again this comes back and this goes back. So this going back, coming back, right, forming, this can be avoided by making, this is resonance hybrid structure. Do you know this? This line, dotted line, indicating the pi bond is getting delocalized, means getting delocalized ka matlab ki keep changing its position, right?
Yes, ma'am.
So pi bond delocalized. This is actually called resonance hybrid structure. So O negative over here. So this negative we can even put in the center. Positive I have put. Okay, negative I can put in the center. So O negative yahan pe shift hua, then this negative to fulfill this bond has shifted. So this is all drama happened because of the negative charge. Correct. So suppose in case if it holds the EWG group over here, present the EWG group. So what this EWG group, it takes the electron withdrawing nature, na? So arrow will be showing towards through EWG group. To fulfill this, pi bond will be completely delocalizing among these three, right? That's the reason we can say this is getting stabilized. right? And delocalization of negative charges we can see. And what effect basically shown over here, minus I effect, which is called the negative inductive effect, which also called the negative resonance effect. Anything can be understood due to this two reason, right? First is the electron withdrawing group nature, which is getting withdraw the electron from the carbon and stabilize the carboxylate anion through the structure, and delocalization of the negative charge by inductive effect or resonance effect strengthen the acidic strength of the carboxylic acid. Correct. Second group, electron electron donating group. So what is electron donating group? EDG. Okay. Examples, we have methyl CH3, we have ethyl C2H5. What do? They decreases the acidic strength. Clear, Hridaya?
Yes,
So
ma'am.
how do they decrease? By destabilizing. See, they did not take the electron from the carbon. They give electron to the carbon. So they do not show the resonance structure over here. Destabilizing is carboxylate ion gets disturbed. Clear?
Yes, ma'am.
Arrow difference you can see. This is the nature of electron withdrawing nature, and this is the nature of electron donating. So they donate electron to the carbon and they destabilizes the carboxylate anion and weakens the acid. Correct. And what do they do over here? Opposite what we can talk as correct. Is this clear?
Yes, ma'am.
This is the nature. Basically, I have talked with you nature of attached group. Okay. So, Hridaya, today's class till 11 o'clock I will take. Today we got late for by 15 minutes. This class in future I'll definitely compensate. But tomorrow onwards, definitely the 9 to 11 classes as usual will go. Okay.
Yes, ma'am.
Hmm. So in case if I get any work, so when will I can compensate the timing? Which time will you be available? In case I get stuck somewhere with the work or something. So what time is suitable for you? Tell the other option.
Ma'am, from 2 o'clock, I'm not free, but so anytime before that,
2 o'clock till
7:30.
till evening.
Yes,
Okay.
ma'am.
Okay. So better we'll finish off in the morning itself, na?
Yes, ma'am.
Let it go in a early time also. Okay, no worry. So we'll continue this property, and today we'll wind up our class by 11 o'clock. So explain now. Here we can have a question like explanation of the acidic strength. So you may have a question like formic acid, acetic acid, and the benzoic acid. So the question goes over here. Explain the acidic strength of formic acid, ठीक है, benzoic acid and acetic acid. ठीक है. So what is the formic acid का formula? COOH. Benzoic acid, benzene, and then COOH. Clear? And then acetic acid is CH3COOH. Okay. So let me tell you, Hridaya, phenyl ring, which is present over here, this ring, and the methyl, which is present over here. Anyhow, these are the substituents we consider for the carboxylic acid. Okay, when we are talking about the phenyl over here or the benzyl will have the minus I effect, means it is showing electron withdrawing nature. Okay, and this compound, this group, because I have given the example, remember CS3 and C2H5 alkyl group, what do they show? Plus I effect. This is called as EDG group. Correct? Electron donating. I did not mention over here plus I effect. Okay? So which increases the acidic strength? Here. Hridaya, are you able to understand?
Yes, ma'am.
Acidic character decreases. So acidic character increases over here and here decreases. Now let me talk on the carboxylic acid में formic acid. So when we are talking about the formic acid, right, hydrogen, so that contains, like, it is obviously it is hydrogen holding compound. So it is more than all other. So only between these two we need to decide. So what we have, the order goes, if we have compound, this consider as the compound 1 and this is considered as the 2, the order goes in the same order what the compound is given. So the first, then second, and the third. Did you understand, Rudya?
Yes, ma'am.
Okay, let's do another example. Another question, not example. So if we do the another question, like we can say same question continued over here, explain the acidic strength. Okay, but what we can say, acidic strength of acetic acid. Okay, we can say chloroacetic acid. Then we can say dichloroacetic acid. And trichloroacetic acid. Clear? Clear, Hridaya, by the
Yes.
name? Okay, let me draw the structure. Acetic acid, CS3. This is acetic acid. Then chloroacetic acid में one hydrogen I'll remove. I'll put CH2. Okay, let me draw like this. It will be more clear to you, Hridaya. Three sides, we have hydrogen. So this is CS3, right? Clear, Hridaya?
Yes, ma'am.
CS3, single bond. And here I am writing one side Cl with attached with the carbon, so it will be monochloro. ठीक है, acetic acid. ठीक है, dichloro में what I will do, two hydrogen I am replacing by the Cl, so only one hydrogen left. ठीक है, C double bond O, OH. This is dichloro. Trichloro के लिए what will I do, all three sides I'll put Cl, so this is trichloro. ठीक है, this is first, second, third, and fourth. So what is the Cl nature, Hridaya? Cl is electron withdrawing group. More the electron withdrawing group, high will be the acidic nature. Correct? So among all these, which has more Cl? The fourth one? Correct? Correct, right? The concept goes like that. Hridaya, are you able to understand?
Yes.
You can see you have 3 Cl right here. And here you have one Cl, and here you have 2 Cl. The more the Cl group, higher will be the acidic strength. Correct? Find? Hriday, are you able to find?
Yes, ma'am.
Then this is the order. Okay, Hriday?
Yes, ma'am.
Clear? Concept is clear? So what EWG group enhances the acidic strength? If EWG group is present, it will enhance the acidic character. If electron donating group like methyl, ethyl is present, it will decrease. That is the reason I have taken acetic acid last, because this has EDG group, electron donating, and this is EWG group. This is EWG group. This is EWG group. Clear, Hridaya? The
Yes.
more the EWG group, higher will be the acidic strength. That is why this is the order. Okay. Then see you tomorrow, Hridaya. Okay.
Yes.
And we'll connect on same time. In case 5 minutes late, I will message you. I'll text you. Okay. See you
Yes.
tomorrow. Thank you so much.